Hello everyone who is listening to this video. I am Dr. Smita Pimpre, Professor at P Society's Modern College of Pharmacy, Pune. Today we are going to discuss about the liquefaction methods for gases. In the previous lecture we studied that critical parameters plays very important role in liquefaction process. So the gas liquefaction, it depends upon critical temperature and pressure. We studied that pressure increased above critical pressure and temperature decreased below critical temperature value brings about the liquefaction of gases. Now, using these principles, various methods are used to liquefy gases. These are Faraday's method, Linde's method and Claude's method. Out of these, Faraday's method is based on simple principle that it decreases the temperature of gas below critical point with the help of freezing mixture. You know that freezing mixture of ice with various salts, it is used for external cooling of the gases. Now these gases are produced or evolved during the chemical reaction. For this particular method, Faraday used a glass tube which is of inverted V shape. So on one side you have reactants which are heated and the gas is evolved which travels through the glass tube, and on other side this limb of inverted V tube is dipped into the freezing mixture. So the gas traveled on this side, it will get cooled and liquefied by means of the effect of freezing mixture. You know that freezing mixture is of ice with salt. So melting of ice in water and dissolution of this salt in the liquefied water both are endothermic processes, and due to this the temperature becomes lower and lower, which will aid in the liquefaction of the gas. The limitation of this method is it can only liquefy the gases whose critical temperature value is near to the room temperature. So we can liquefy gases like sulfur dioxide, carbon dioxide, nitrogen monoxide and chlorine, but the gases whose critical temperature is far below than room temperature, for those gases this method is of no use. So like oxygen and air, it cannot be liquefied with the help of Faraday's method. Now for such type of gases, methods like Linde's and Claude's were used for liquefaction. Now we will discuss about Linde's method of liquefaction of gas. It is based on the Joule-Thomson effect. According to this effect, when a highly compressed gas is allowed to suddenly expand into a vacuum or a region of very low pressure, then it produces intense cooling. In compressed gas, the molecules are very closely associated and the attraction forces between them are quite appreciable. So as the gas expands, the molecules move apart, and in doing so, the molecule has to break the intermolecular forces of attraction. Now the energy which is required for breaking of these bonds, it is taken from the gas itself, and because of this there is cooling and subsequent liquefaction of gas. Now this is diagrammatic representation of Linde's apparatus for liquefaction. Here you can see there is inlet for fresh air. That air is compressed under very high pressure, and this compressed air is passed through a jacketed tube. That jacket is filled with refrigerating liquid like liquid ammonia, and this cooled and compressed gas is allowed to travel through a spiral tube, and it is suddenly exposed to area of very low pressure. So this sudden expansion will affect into losing kinetic energy, cooling themselves, bringing molecules in the sphere of van der Waals forces of interaction, and thereby liquefaction of the gas. Now, why there is use of this spiral tube? This spiral tube is used just to increase the traveling path of the gas molecules so that they will get further cooled by the surrounding cool gas inside the chamber, and it will aid into the liquefaction of the gas. So the gas which is liquefied, it will get condensed and settle down in the bottom of this vessel, and the gas which is not cooled sufficiently and got liquefied, it is again returning back to the compressor. So such cycles will eventually liquefy the gas. So this is Linde's method for liquefaction. Now we will see some advanced version of this method, that is Claude's method. Claude's method is more effective than Linde's method. Here, the liquefaction effect is enhanced by means of forcing the gas to work against a piston. Means the gas molecules which are cooled, instead of sending these cooled gas molecules back to the compressor, these molecules, they are allowed to perform certain work by pushing a piston which is attached to this vessel. So this is going to further affect in losing energy and enhanced cooling as compared to the Linde's method. So this is quite more efficient. The cooling is produced by free expansion of compressed gas. In addition, the gas is made to work by driving an engine, or that is nothing but the piston. The energy for this comes from the gas itself, and which will eventually lead to cooling of the gas molecule. The gas is cooled not only by overcoming the intermolecular forces of attraction, but it is brought about by performance of work also. So this is efficient method as compared to Linde's method. So this is all about liquefaction of gases, the principles used, the methods used, instrumentation and working. Now, application of liquefaction of gases in pharmacy, it is involved in the manufacturing of aerosols. Now, students, this is a figure which is representing the container, that is aerosol container, along with its components. So you can see here a can is there, a container is there, which is fitted with a valve assembly. It is having a valve with actuator where you can press it and the drug will emit from the orifice, and this valve or actuator is attached to the dip tube which is going down into this container, and it is used for expelling the content outside this orifice. Now the aerosols, it has two important components as far as the formulation is concerned: product concentrate and propellant. So propellant is nothing but a liquefied gas which is used to build the pressure, and this pressure is responsible for expelling the contents outside. And product concentrate, it is nothing but the mixture of API, active ingredient, along with some excipients like some suspending agents or emulsifying agents if required in case of two-phase systems, and either liquid propellant is used as a solvent or sometimes separate solvent is used. So together it will constitute product concentrate and liquefied propellant. Now the propellants can be of two types: a compressed gas, examples are nitrogen or carbon dioxide, and a liquid, that is liquefied gas, examples are butane, isobutane, propane, or CFCs, these are chlorofluorocarbons which are used initially but there was concern with the use of CFCs that they deplete the ozone layer in the atmosphere. Hence, after 1980s, their use is completely banned, and now CFCs are not used as propellants. So drug is just dissolved and suspended in propellant, and vapor phase propellant, it exerts pressure on the surface of liquid product concentrate, which will help in expelling the product after actuation of the valve assembly. So this is the application of liquefaction to the aerosols. Now during manufacturing process, the propellant is liquefied using low temperature and high pressure, and it is filled into this container. Upon actuation, the pressure is released, and the liquefied gas, it is along with product concentrate, it gets expelled from this orifice when it comes in contact with external atmosphere, leaving the product concentrate in the form of fine particles or globules or fine sprays. So this is how actually aerosol works. Herewith we completed the gaseous state of matter, and we will revise just the contents in gaseous state. First we have studied the intermolecular forces of attraction, in that intramolecular as well as intermolecular, then transition of states of matter, properties of ideal gases and real gases, kinetic molecular theory, derivation of ideal gas equation with the help of gas laws, correction in that equation by means of van der Waals equation for real gases, then compressibility factor, which tells us about the deviation of real gas from ideal behavior, then critical parameters, critical pressure, critical temperature, and critical volume. Use of this in liquefaction of gases, different methods to liquefy the gases, Faraday's, Linde's, and Claude's, and application to aerosols. So students, I hope you understood the contents I have delivered through this series on the topic gaseous state. Thank you for watching the lectures, and I will appreciate your feedback on these videos. Thank you so much. Happy learning.